So I'm going to be going over how to do this modulo stuff without using his method. We're going to do it using binary numbers, which I think is simpler. So let's take a number, 40 mod, let's make it big, something he would put on the exam, 313. I seriously doubt it would ever be 1,000. That would just be ridiculous. But anyway, so the first thing we're going to do is we're going to convert this number up here into binary. So to do that, there's a bunch of YouTube videos on how to do binary conversion, so I'm not going to get too into it. But basically, divide this number by 2. If it's an odd number, there's going to be a remainder of 1, basically. So that's going to be 156. Divide that by 2. That's going to be remainder of 0. 78 divided by 2, remainder 0. 39 divide that by 2, remainder 1. 19 divided by 2 is remainder 1. 9 divided by 2 is going to be remainder 1. That's going to be 4 divided by 2, remainder 0. 2 divided by 2, remainder 0. 1 divided by 2 is 1. So this is your binary number here. And you start writing it from the bottom. So you write this one first, and then this 0 next. 0, 1, 1, 1, 0, 0, 1. And if this was a shorter number, like if it was only 5, you would add zeros until it equals 4 or 8 or 16. But that's like a whole different thing. So anyway, so this is the binary number that we got. Let me remove this. So this is our binary number for that 313. Now each one of these binary numbers have a value, a power to them. So this is to power to 1, to 2, to 4, to 8, to 16, to 32, to 64, to 128, to 256. And it would double. Anything further is just going to double these every single time. So, but I doubt there would be anything like that on the exam. So the next thing we're going to do, and I recommend that you draw this big so you can use it as a reference so you don't get lost. So it's going to be, we're just going to write 40, 40 all the way through. And it's going to be 40 to the power of 1, to the power of 2, power of 4, 8, 16, the same that you see up there. Yeah, the audio is bad, but MSC was the best place I could find. Okay, so now we're going to compute modulars. Now, the modular, I'm just going to write mod, but it's mod 17. And to do that, you divide the number. So let's say, you divide that number and you get well, I'll show you in a second. Okay, so 40 to the power of 1 is 40. Then we mod that. So 40 basically divided by 715. It's smaller than that, so it's obvious. So it's always gonna be a remainder. If it's smaller than this number, the remainder is always gonna be 40. So, or the number that's smaller. So we just get 40. So we put 40 over here and we square it. Let me actually put that in white so that I'll explain why later. So this is 40 squared, and then we mod that. Or actually, first we do that. Okay, so this is 1600, and then we mod it. So that's gonna be 1600 divided by 715. We're going to get a number like 1.4, and then we remove this 1, so we subtract 1, and we get 0.4, and then we multiply that by 715. So in this case, 1600 mod is going to be, let me put that on the calculator, 170. Then we put 170 up here, we square it, and then we get 2890. We mod that, and we get 300. So now we go back over here, we take 300 squared, that is 90,000. We mod it. Now 90,000 mod is 625. So we put 625 up here, squared, that is 390. And then we mod that, and that computes to 235. And then you just continue doing this down the row. So 235 squared, what is that? That is 55225. And then we mod that, and we get 170, right? Yep, okay. All right, so now 170 squared, put it over here. And since we actually already did 170 over here, we don't have to do it twice. When it won't always happen, but we just know that it's 300. So it's going to be 300. And actually, again, we did 300 over here, so it's going to be 300 squared is going to equal to 625. And then we already did 625 here, so yeah, that's crazy. Okay, so 625 squared is going to equal to 235. Okay, so now here's the important part. This is why we use binary. So these numbers that are equal to 1 are the only important numbers. We don't care about, once we're done with this computation, we don't care about zeros, so we can just forget them. So now 313, mod 313 is equal to 40 mod 256 plus 32 plus 16 plus 8 plus 1. And if they give you like, oh, you're missing these numbers, well, you can get them from this, and that's how you find those numbers. If there's like a question like that on an exam, because there was a bunch of them in the homework. So that's how you get these. Now, the modulars, the things that were left over under the ones, are the ones that we have to multiply to get our modular of 313. So let me just delete this. And so all the ones that are under ones, so in this case, 235 times 170 times 235 times 625 times 40. So that is what we need to get the mod of 40 to the power of 313. So now we're just going to let's just multiply these numbers, and let's multiply these numbers. This number comes out to a big ass number. Okay, so 9388250, and this number comes out to 25,000. Way smaller number. Now, if we multiply these numbers, it would be massive. Like we would not be able to. It would kill the calculator. So we're going to mod these numbers, each one individually. So this number modded by 715 is 300. And this number modded by 715 is 690. Now we'll multiply these two numbers together. So 300 and this one. And they come together and become, let me make this smaller for space, 207,000. Then we mod this number by 715, and the result is 365. So this is our answer. This is mod of 40, or 40 to the power of 313, mod 715 is equal to this number right here. That's the correct answer. And if they ask you for what's missing, you know how to, you know that it's this number, this one, this one, this one, and this one. These are the important numbers that are relevant to how you get 313. So that's how you do this using binary. This is a terrible explanation, I'm aware. Bro, I got so much respect for my chemistry tutor. This shit is difficult.